Greetings, guys. Let's talk about some identities that contain double angle formulas. Now, the thing is, the more formulas you know, actually the easier it is to get identities completed. See, when it comes to something like this, cosine 2 theta, well, we used to have to do it the old-fashioned way and write, well, that means cosine theta plus theta. Then we'd have to expand it. I'm going to stop right there. We'd have to expand it out, etc. But now we know better. I'm going to erase all that information and say, we know better. Cosine 2 theta, we could write it as cosine squared theta minus sine squared theta if we wanted to. Or we could use the different other versions of this formula that we know, where we have, hey, maybe it's 2 cosine squared theta minus 1. Maybe that's the version of this formula I want. And then we have one more, 1 minus 2 sine squared theta. Whoops, kind of wide on that. But the thing is, the more we know, the more options we have. So I'm going to tell you right off the bat, I could use any of these to make my identity work out. I don't have to show all the work I used to show this, because once we cover a formula, you should own it. So that streamlines the process and makes this so much easier. So I got to tell you, one of these three candidates on the left side of the screen is going to be the way out. Now, on the right-hand side, though, I'm going to have to do some manipulations. So just remember, in mathematics, be polite. How are we going to do this one? We're going to have to do a little bit of both sides to get this to work out. But I'm going to do this right-hand side two different ways, because I want you guys to kind of embrace the fact that just because you see it one way doesn't mean there's not another way to get there. So let's look at it on the right-hand side. So I know what the left-hand side is going to turn out to be. It's going to be one of these guys. But the right-hand side, here's type 1. I could have done it this way. You know what? I know that secant squared is the same as 1 over cosine squared theta. I could do it this way if I want. Then in the bottom, I could say I've got the same type of feel, la la la. See? And then I go, wait, I got a double fraction, no me gusta, so I'm going to, oh, grab the wrong pen. I'm going to grab a red pen here, and I'm going to say, you know what, if I took the entire top and the entire bottom of this, and I multiplied it by cosine squared theta, which is the LCM, this is the easy way to get through here, I could, get 2 cosine squared theta, right here in the top, 2 cosine squared theta, minus, well, this would cancel, minus 1. And then I can easily look at this and say, this should have been the way I rewrote my cosine double angle. That is one heck of a quick, slick way to do it. But you do have to show some work. So let's pretty this up a little bit more, because I want to remind you that there's more than one way to do this. So I'm going to get rid of some of these markings I made to get things out of my way here, make it a little less noisy, because I can tell you right now, if I want to get this problem done on the left side, that would be my only move. I would say that's how it's going to break down if you look at the information they gave you on the right. But let's do this. I'm going to get rid of this information here and say, let's try it again. But this time, watch how I visualize it this time. If I want, they both have a common denominator. And I could say, you know what? My first step is going to be to rewrite it with a common denominator. I could simply split the fraction, and then when I look at it, I say, oh, this is the same thing as, and if you're going to write out every single step, you could say 2 times 1 over secant squared theta minus, and then these would both cancel. I'd get 1 if you were going to be super duper formal about it. And then this guy right here, what is he? Oh, he's just the reciprocal of cosine. So boom, there we go. Both sides equal each other. We are done. It all depends on how you visualize it. But what I'm trying to get at in this lesson is things, whoops, there we go, come on, there we go. Things that we had to work for before are now given to us because we understand that there are more formulas out there. And really, guys, got to tell you, in your future, there's more formulas out there. So the more you know, the quicker it is to rewrite stuff the way you want it. So that was my first example. I did it 2 different ways. Let's talk about the next one. Let's look at the next example. So here's my next example. And I wanted to give you guys one of these because, hey, 2 cosecant 2 theta. Wait a minute, what is that all about? Well, we don't have a cosecant double angle formula. We do not. But we can rewrite cosecant as its reciprocal, and then we're in business. So I'm going to tell you, when I do the one side of this problem, it's not going to be the end of everything. So I'm just going to tell you right up front, this is a both. I'm going to work on both sides of this identity. And just a reminder, you do not get to treat this like an equation. You can't add the same thing to both sides or multiply the entire thing by some value. Identities are when you make either the left look like the right look like the left, or you make both of them look like the same third common thing. So I'm going to start off on the right because I go, you know what? This whole lesson is about looking at things that we can do with double angles. So I'm going to say this is the same as 2 times, and I'm going to put it in parentheses just because I think it looks prettier. 2 times that. That's what it looks like. 2 times cosecant double angle would be 2 times that. Now, if it makes your brain happier, you can make it look like that. But what I'm trying to get at is, I know a formula now for this guy. I know a formula. And I could say this part of the picture right here, working vertically, is the same as 2 sine x cosine x. I'm going to multiply that by what? By 2, and if it makes your brain happy, put the 1. And then I hope you see this. Kaboom, kaboom. Those guys cancel. Number cancels number, right? We're back to reducing a fraction. So the whole right-hand side boils down to, this is what it looks like. Well, that is certainly not what the left-hand side looks like, but we can get it there. So I'm going to take this side and I'm going to say, you know what? My right-hand side is all sines and cosines. It is. It's all sines and cosines. So let's start first step by rewriting these guys. I'm going to say this is sine x over cosine x plus this guy is cosine x over sine x. And then I say, what is the indicated operation? The indicated operation is you're going to add these 2 things together. So if you're going to add these 2 things together, you need common denominators. So let's get I'm going to get a different colored pen, and I'm going to say, you know what? You need a sine x. And if you had a sine x, you would have the same denominator as this guy if he had a cosine x. And whenever we go through rational expression stuff, it is so important in all of your future mathematics to understand what is the indicated operation. They want me to add, I need common denominators. But you know what? Once I get them, what's in the bottom? I have sine x, cosine x. That's what I have. Let's clean up the top. So here, first things first, sine x times itself, well, I call that sine squared x, plus cosine times itself, I get cosine squared x. And then I go, dang, I know you very well. You are such a well-known dude. I'm going to call you 1. The top part of my fraction is now a 1. The bottom part of my fraction is this. And do me a favor, when you are doing an identity, don't just stop right here. Be polite. Show me that these two things that have nothing to do with, come on, these two dudes that have nothing alike in the beginning, you have to show the steps that the left side and the right side both eventually equal the same dude. So that is a formal, beautiful identity being proven. And how are we doing this? We're using double angle formula stuff to streamline stuff. So we got one more. I got one more, and then you guys should be able to knock out the problems I'm giving you. But you might look at this one and say, whoa, this one looks really beefy. And once again, there is no secant double angle thing. I don't have one of those. But I do have a cosine double angle, and I could say this dude right here is going to turn out to be 1 over cosine 2x. But which version of that? Because remember, we got 3 different ways we could draw that out. And heck, I'm just going to write them out just to remind you. We got 3 different ways this could look. It could look like that. This thing could look like that. It could look like this. Oh, I almost made a theta. Or it could look like this. This little piece could turn out looking like either 1, 2, or 3. So I'm going to get that out of our way for now. I'm going to get rid of this stuff. Sorry, guys. I just want to make sure it's out of my face, give me some room to work. I'm going to erase this. But I do know that if I'm going to show you how the left side equals the right side, I'm going to be messing with both sides. So on the left-hand side, I know it's going to be 1 over cosine 2x, but I don't know which one of those 3 dudes I want yet. And I look at the right-hand side, and I'm hoping you see exactly what I do. This is a factoring identity. I got to figure out a way to factor this thing. That's my technique I'm going to go for, because in the top I see a big, juicy GCF. I do. I see a big old GCF in the top. So I could do that to start with this problem, and that's what I'm going to say, you know what? Let's see if that leads me anywhere. Now there is another way to do it without seeing this GCF. There is. But whenever I see a GCF, it just makes me so suspicious. Like, what is the rest of this problem going to hold for me? Did I do that part right? Yeah, I did. I took out the secant squared x. Now, that means the bottom is a trinomial. So I'm going to go, you know what, you trinomial? I'm going to try and factor you. To get a 2 out of this thing, I'm going to guess it's 1 times 2. I'm going to guess that. I need a secant to the 4th, so I'm going to assume that over here is a secant squared x, and over here is a secant squared x. But I need it to be a negative, so what the heck? It's either going to be a plus and a minus, or it's going to be a minus and a plus. But, you know, I'm going to assume this is the way it goes, because look, boom, then I would have a match. So before I do that, ding, ding, let's make sure I was right. And I'm going to erase all this stuff, but do you see that that would be positive 2, take away one of them, that would be what we need in the middle. I'm going to take away that little check I just did, because I want my work to look prettier. And then I am going to say, hey, kaboom, and then what do I have in the top? I have secant squared x, and then in the bottom, what do I have? 2 minus secant squared x. And I go, hey, wait a minute. This is starting to look super familiar to me. I know it. I'm going to do this. On this hand, this side, I'm going to say this is my dude. That's what I want this to look like. How do I do that? Well, how did I see it that way? Well, it looks like to me that it's very similar to my first example. Now let me scroll up. I just want to show you guys this. Hold on, keep this in mind. I'm going to come right back to this, but let me scroll up. My very first example, look, I had it like that. Now the difference between my problem now and this problem isn't theta. Oh, you're using x now, not theta. No, this is the reciprocal of what I have now. So be careful. In the very first example that I showed you guys, I was able to split the two fractions. That was one way I could do it. In this one, I have no choice. If I want to get this right, I have no choice but to do the double fraction trick on this one. So here we go. Grabbing my red pen, I'm going to say let's multiply everything in the top by cosine squared x, everything in the bottom by cosine squared x. Right here, kabam, kabizzle, what do I get? I get a 1 in the top. In the bottom, I get 2 cosine squared x. But here, bam, bam, that would cancel. And that's when I match and I say, oh, they are the same guy. See, when you learn more formulas, it saves you time. It saves you time. So these identities that I just kind of went through and worked out for you, you know what? They're going to help you do these ones. These are the ones I want you to practice from the book. On page 230, 231, I picked out these 5 identities. All right, so we got to practice some identities, and technically the good news is if you can do these, you should be able to do anything I throw at you. So good luck. Good luck. Ask questions if you get stuck.